Satyabama Institute of Science and Technology.
Hello everyone, myself Vinothini, Assistant Professor, Department of Computer Science and Engineering, Satyabama Institute of Science and Technology. Today we are going to see the lecture about in data structures, that is tree. So before that, going into tree, we have to know what is a data structure. So data structure, by the name itself, we can know data and structure. Data is a collection of data that we are arranging and organizing in a structure for easy accessible. Okay, so storing and organizing data in a computer. So basically data structures of two types. One is linear and non-linear. So here the linear data structures are array, linked list, stack and queue. So if you see this array, linked list and stack, queue and all the data are arranged sequentially, continuously in a continuous manner. So non-linear data structure, tree and graphs are there. So today we are going to see what is a tree. So the basic logic of tree we already know in a real time example, the common tree we can take it. The tree starts from root, stem, branches and leaves. The same thing how we are going to store the data. Here the root is the main thing. So in the real time, real world example, we can take this as an example. First one is a chairman is the main person, that is the root for the, if we take the example for the college, means management. The chairman is the main person. Under that some directors will be there and then the HODs will be there. Under the HODs only faculty members will be there. It's like a tree-like structure. So all the data are stored in a hierarchical model. Okay. So starts from root and ends in the leaf. So we have to know the definition for the tree. Tree is, as I already said, tree is a non-linear data structure which organizes the data in a hierarchical form. So root is the main source, is the basic for all the trees. So this is how the structure of the tree will look like here, where we are going to store the data. So the first thing in tree terminology we have to know is what is a root. So root is a first node, as I already said, that is the basic node. The root node doesn't have any parent node, okay. It will have only the children. So here they have labeled the root node as A, okay. And then the second thing we have to know is what are the edges. Edges is nothing but in the tree, the nodes are connected using the edges, the lines that draw between the nodes or the edges. So here all the nodes are labeled like with the alphabets of A, B, C, D, E, F, G, H, and they are connected with the edges, that is lines. Okay, here if you calculate the total number of nodes and if you minus it by 1 means you will get the number of edges. Okay, for example, you can count the number of nodes, how many number of nodes are there, that is n, and minus 1 if you do it means you will get the number of edges. So the next node is we are going to see is a parent node. Parent node is the predecessor of any node, okay. So whatever nodes are there, if it has the predecessor, that is the parent node. So the root node will be a parent for B and C, and D, E, F has the parent is B, and C is the parent of G and H, okay. So next thing is a child node. Child node, what are the nodes that comes under any nodes? Okay, for example, B and C, we are starting it here from B and C. B and C is the child node of A. So D, E, F is the child node of B, and G and H is the child node of C. So what are the nodes comes next to the nodes or the child nodes? So next node is a sibling node, a parent node. Each parent will have n numbers of children. So all the children's nodes are called sibling nodes. So here if you check the diagram, B and C are the siblings. Why? Because for both has the same parent A. So here D, E, F or siblings has the parent of B. Okay. So like that all the nodes which are parallelly present have the single parent is called the sibling nodes. The next node is a leaf node. A leaf node is nothing but is the last node that don't have any children. It has only the parents. Okay. So here the remaining nodes, this is the root node and these are the leaf nodes. The nodes present in between the root and leaf are called the internal nodes. Okay. So these are the internal nodes. The internal nodes, it has at least one children, but it's not the leaf node. Okay. So as I already said, there will be a root node and the last nodes are the leaf nodes. The nodes that present in between is the internal nodes. So then there's the degree for a tree. So how we can find the degree of the tree is nothing but you have to calculate the childrens. For each node, how many childrens are there? For example, A has 2 childrens, B and C, and B has 3 childrens, D, E and F. So the degree of A means for this tree. So how many degrees are there? We have to calculate it. So A has 2 children, B has 3 children, and then C has 2 children, and E has 2 children, and G has 1 children. Okay. So the degrees are for 2 children's 2 degree, 3 children's 3 degree, and 1 children's 1 degree, and there is no children for his at 0 degree. Okay. So that is how you have to calculate the degrees. And then we are moving on to the levels. The levels is nothing but how many levels are there in the tree from root to up to the level where the leaf nodes are present. Okay. So we are calculating the levels from 0, that is the root node, we are calculating as 0, level 0, and then level 1 and level 2. Okay. And then the height. So always the height must be calculated from the leaf to the root. Okay. So if you want to calculate the height, you have to find how many edges are there. Already you know what is the edges, I already said. So edges is the line, but for finding the height, you have to calculate the, you have to count the edges from leaf to root, from bottom to top. So here for calculating the height, you have to count the edges. Height from K to A means from the leaf node to the root node means you have to calculate it, you have to count the edges from leaf node to the root node. So if I count it means 1, 2, 3, 3 edges or this, so the height is 3. If you want to calculate to the B means B is not the root node, but you want to calculate the height till B means you have to count the edges 1 and 2, so 2. Okay. So based on by counting the edges only you can calculate the height of the tree. And then the depth. So depth is nothing but we have already calculated the height by bottom to top. Now we are going to calculate the depth by top to bottom from root node to the leaf node. So from root to leaf we have to count the edges same. So the number of edges from the root node to the leaf node is the depth of the tree. So based on the path, depends on the path, what path you are selecting, you have to calculate the edges from root to the leaf node. So the next thing is the path. Path is we have to select in which path we are going to select the data. So based on the path you can calculate the nodes or edges. Okay. So here they have taken the path from A to J. You can calculate the nodes, how many nodes are there, how many edges are there. You can get the longest path in the tree. Okay. So next thing is the subtree. Subtree is nothing but instead of removing means omitting the root node, you have to calculate how many subtrees are formed using the child node. Okay. So here the root node is A, but the child node for A is B and C. So from having the base of B and C, there is a subtree you can form, and from there E is there, and E has 2 children, and this is one kind of subtrees. Okay. So n number of subtrees can be formed from one main tree. So next thing we are going to see what are the types of trees. The first thing is general tree, binary tree and binary search tree. So general tree is nothing but general tree is the common tree. Data structures what we already seen. It has the root node, parent node, child node, siblings, everything, and the height will be calculated, the degrees and depth, everything will be calculated. What we have already seen, that is the general tree. Next thing is a binary tree. Binary tree, by the name itself you can understand binary 2. Okay. So binary means it should have at least 2 trees, 2 children at the end. So it starts from root and it has 2 children either left and right side, and each nodes in left side and right side should be completed with 2 children. That is the binary tree, and the height will be calculated as it is based on left and right. So both left side and right side have to be equal. Left side one node and right side one node. 2 children have to be there. And how the binary tree is represented, as I already said at the starting of the slide itself. So array and linked list, it's a sequentially arranged data types. So we can do both in binary trees also. So how the array will be represented like the tree form. So A, B, C all the nodes are labeled as alphabets, and you have to count how many nodes are there totally. There are 7 nodes. In array, how it will be arranged is, so the total number of nodes will be placed in the array of 0, and the remaining A, B, C, all the labeled nodes will be, all the data will be stored in the sequence, continuous order from 0 to 7. And how the linked list represented in array is, the normal common tree will be there, and each node will have the address link of the previous and the next node. Okay, so for example, if you are saving the data, A data is saved, okay, but previously we have saved B, and then next we are saving C, means the A will contain the address of B in the front and address of C in the right side. Okay, so left side and right side, both the address of the previous and the next data will be stored in the middle node. So binary tree types. So first is extended binary tree, complete binary tree, full binary tree, skewed binary tree, strictly binary tree, and expression binary tree. So first thing is the extended binary tree. Extended binary tree is nothing but the incomplete binary tree will be extended to form a full binary tree. For example, check in the image. So A, B, C, all the nodes trees are there, from starts from root to leaf, but what I already said, binary tree must have at least 2 children at the end, but here it's an incomplete binary tree. Why? Because B has only 1 children. So you have to complete this binary tree by adding the special nodes or failure nodes. So the box, the rectangle box with this color is the, we are giving the special nodes for making it a complete binary tree. So the extra added nodes are called external nodes, and the nodes that present in between the root and leaves are called internal nodes. Okay, so internal, external nodes are there. Next is complete binary tree. Here if you check the image, means A node is there, the root node, and each root node will have 2 children. And why we are calling it as a complete binary tree? Because it starts from left to right, all the trees are being completed with 2 children. So fully binary tree, full binary tree is, as I already said, all the nodes will be completed with 2 children. So if you check the image, means you can see all the nodes will completed with 2 children for each. So how you calculate the number of nodes here in full binary tree is, so 2 to the power of h plus 1 minus 1. So 2 to the power of h plus 1 is, h is nothing but it's a height. Okay, so height plus 1, you can calculate the levels of 1, 2, 3, 0, 1, 2, 3. 3 levels are there. So 2 power 3 plus 1 is 4. So 2 power 4 is 16. 16 minus 1 is 15. If you calculate the count, the node, means you can have 15 nodes there. So skewed binary tree is nothing but the subtree that you are forming either left side or right side. If the subtree is formed in the left side is the left skewed tree, and the subtree is formed in the right side is called right skewed tree. Strictly binary tree is strictly it should have 2 children or else 0 children. If you check the diagram, means you can understand easily. B has 2 children, C has two children, and G has H and I 2 children, but either no nodes are having even a single children. Either it should have 0 or 2 children. So expression binary tree, by the name itself you can understand expressions, that is Boolean arithmetic logical expressions. Okay, here the 2 things we are using, one is operators and operands. So the expression binary tree, if you check in this diagram, you can easily understood all the operators are present from root to the internal nodes, and all the leaf node contains the operands. Okay, so operators are there and operands are there in the leaf node. So how the calculation will be done? So from the leaf node, the calculation have to be done, B star C have to be done, and the result plus A. So from the bottom to top, the calculation have to be done. At last, left side plus right side, it's done. So next thing we are going to see is the binary tree traversal. It is of 3 types. One is pre-order traversal, in order, and post order. The traversal, by the name itself, you can know that it will travel. Okay, so it will travel from each node. It will visit each node at least once. So what is a pre-order traversal? Here the nodes will be visited like root node first, and then left subtree and right subtree. So root node, left and right will be done. This is how the way it will visit the nodes. In order, the first node will be visited is the left subtree, and then root, and then right subtree. And the post order, the post order, the left subtree is visited and then the right subtree is visited. At last, the root node is visited. So here is the diagram for all the in-order traversals, in-order, pre-order and post-order. So in-order traversals, the first left side is visited, no? So 1, 2, 3, all the left side is completed and then root node 4 and then the right side 5, 6, 7. So in pre-order, root node is visited first 4 and then the left side and then the right side. The post order, left side, right side and the root node. If you check the diagram means you can understand it easily. Thank you.